This is Advanced Math, Unit 8, Lesson 2. Today we're working with quadratic inequalities. And for the most part, for the first part of this, it's going to be review. All right, graph and express in interval notation. Number 1, x is less than 3. And again, this should be review for you from last year for Math 3. When you do this, and actually this first part is review from elementary school. There's no bar at the bottom, which means it's not equal. So it is an open on the 3. Not, if it was closed bar, it would be closed. If there were a bar, it would be a closed circle. And you read this, x is less than 3, which means it's opening that way. There is your graph. If you wanted to, you don't want to draw an arrow, you can shade this in. You do not need both of them. I'm just showing you the arrow or shading in, either one, to show your graph. Now, express at interval notation. This is the review from last year. It's coming from negative infinity and stopping at 3. Parentheses always on infinity, and because this is an open circle, it's also parentheses. That you learned last year. All right, so this first part again is just review. Number 2, x is greater than or equal to 4. So you make your number line, 4, and because of the equal bar, you close it in, and when you read that, it's x is greater than equal to, which means it's opening to the right. And if you wanted to, you could have shaded it instead. It's totally up to you. All right, it starts at 4, and it goes off to positive infinity, always parentheses on the infinity. 4 is closed in, so it is a bracket. All right, and just in case you've forgotten, I will write it over here on the side. If it's less than or greater than, it's going to be open circle with parentheses in your interval notation. If it's less than equal to or greater than equal to, it's going to be a closed circle with brackets on your number. Okay. Number 3. Kids always get stuck with this one. It's a really easy one, but they just get stuck, so I do want to go over it. X equals -5, and they struggle with how to graph. How do I graph that? It's the dot's at -5, and it's equal to, so you close it, and because it's only -5, that's it. That is your graph, just a dot at -5. It's not greater than -5, it's not less than -5, it is only -5. And then your interval notation would look like this. It's just -5. Starts at -5, ends at -5, and that is it. Number 4, -1 is less than x, which is less than or equal to 6. Now again, I'm sure you learned this last year. -1 is less than x, and x is less than or equal to -6. So when you and-wiched between the two numbers, it is an and problem. I'll repeat that. When you see the x and-wiched between two numbers, it is an and, not an or. All right, so one way to rewrite it is write that part first. -1 is less than x is equivalent to saying x is greater than -1, and x is less than or equal to -6. I'm going to write just like that. And I don't know if I said -6. I did not mean to. If I did, that's +6. All right, so x is greater than -1. I rewrote here. X is less than or equal to 6. I wrote there. And then we graph it, and then interval notation. Okay. -1 on the left, 6 on the right. -1 is open because there's no equal bar, where the 6 is closed because of the equal bar. And I'm going to go back and bubble this in so it doesn't get blended in with everything else. All right, x is greater than -1 means I put my arrow to the right because everything to the right of -1 is bigger. X is less than +6, which means my arrow is going to the left because everything to the left of 6 is less than. And remember with and, Whenever there's an and problem, there must be overlap when you graph. If there is no overlap when you graph, then it is no solution. And you will see some of these eventually, but remember, if you graph and it's an and problem and it looks like this, like the arrows are going away from each other, that is a no solution. If it was an or, it would work, but for ands, there must be overlap. All right, so what you do is you shade the overlap. You either do a little like this or you shade in the middle right there. Either way, leave the arrows outside because that's part of showing your work. Just darken in the overlap and the overlap right in the middle. So that means the number has to be between -1 and 6, but it does equal 6. So -1, comma 6, bracket on the 6, parentheses on the -1 because it is open. And that is your interval notation. All right. Next piece, solve and graph. And I'm going to put here also interval notation. All right, so it's going to be like these up here, but except you're solving, and then graphing and interval notation. Number 1, 3 is less than x plus 2, which is less than 7. All right, because it is an and, you are able to rewrite it like we did here. You can do exactly that. 3 is less than x plus 2, and x plus 2 is less than 7. Or, because there's only one x in the middle and there's no variables on the outside, I'm sure you were taught this last year. If not, here we go. You just solve it all in one step. Crosses out in the middle, which is what we were hoping for. And then 3 minus 2 is 1, is less than x, which is less than 7 take away 2 is 5, and that there is your answer. And I take a step back. Technically, this is not your answer because I solved it. Yes, I did. But I still need to graph it and write it in interval notation. So I have multiple answers. Here's my first for the solve. Now I'm going to graph. +1, +5. They're both open because there's no equal bars. When I read this, this is saying x is bigger than 1. Can you guys see that? It's eating the x, so x is greater than 1 means everything to the right of 1. When I read that, that's saying x is less than 5. X is less than 5 is everything to the left of 5. So what numbers are bigger than 1 and less than 5 at the same time? Everything in between. So earlier I did a little rainbow type thing here, just a squiggly, totally up to you and how you do your work. All right, now interval notation, 1, 5. They're both parentheses and there's no infinity because it does not go either way forever. The overlap exists only between the 1 and the 5. That there is your answer. Okay, now what if you had one that did have multiple variables? Because I said you could only do this little trick if it did not have multiple variables. So number 2, 4x plus 2 is less than or equal to 3x plus 1 is less than or equal to 4x minus 5. Now if you had something like this, do you see how there's x's on the outsides? You can't do this little trick that we did over here. On this one you will have to rewrite 2 separate equations. That will be one and that will be the other with an and in between. So that one would have a little more work. 4x plus 2 is less than 3x plus 1 and we know it's an and because it's a sandwiched between 2 pieces. And then the middle again, 3x plus 1, that's the part that's sandwiched, is less than or equal to 4x minus 5. And then you solve as you usually would. Subtract the 3x. X plus 2 is less than or equal to 1. Subtract your 1. X is less than or equal to -1. And we solve the other one over here by subtracting the 4x. 3x take away 4x is -1x, plus 1 is less than or equal to -5. Subtract the 1, negative x is less than or equal to negative 6, because negative 5 minus 1 is negative 6. And because there's a negative there, I do have to divide by the negative 1. And remember, with inequalities, when you divide by a negative 1, it does flip your inequality. X is greater than or equal to positive 6. All right, so when we graph, we're going to have it like this: the negative 1 here, the positive 6 there, closed on the negative 1, and it looks like it is also closed on the positive 6. X is greater than negative 1, that means everything to the right. X is greater than positive 6, and I apologize, did that the wrong way. I read it incorrectly, and I will fix that. This does not say greater than, that says less than. X is less than or equal to negative 1, that goes this way. This says X is greater than positive 6, it goes that way. Now I just said earlier, with ands there must be overlap, and since there is no overlap here, there is no solution. Now kids often say, all that work and there's no solution. Technically, this here is what I'm looking for. Yes, no solution is the final answer, but when I check your work, I'm looking that you understood how to get to the no solution, that you were able to break it apart, solve and solve, graph, recognize that and needs overlap. This one had no overlap, therefore it is no solution. All right, number 3. X plus 4 is greater than 16, or 2x minus 1 is less than 7. Now this one's or, it's already broken up. Ors will always be broken up. It can never be written as a sandwich, so you don't have to worry about rewriting. You just go through and solve. X is greater than or equal to, nope, just greater than, and 16 take away 4 is 12, or 2x is less than 8. Divide x is less than 4. So I have x is greater than 12, or x is less than 4. All right, now we're going to graph. Here is the 12, and nope, I'm going to fix that. Smaller number on the left, positive 4, and then the positive 12. Open on both. X is bigger than 12 is to the right of 12. X is less than 4 is to the left of 4. Now with ors, does not have to be overlap. It's either or. X is bigger than 12, or x is smaller than 4. So 0, 1, 2, 3 would work, even negative numbers. And 13, 14, 15, 16 up on to positive infinity would even work. So that's your solution, everything to the left and everything to the right. Interval notation, negative infinity, comma 4, because I'm going from negative infinity to 4. Parentheses always on infinity. 4 is open, so it also has parentheses. Don't forget your union. You learned that last year as well. Parentheses because it's open on the 12, comma, positive infinity, and parentheses because it's always parentheses for infinity or negative infinity. All right. I'm going to now, everything I've done so far has been review. I'm going to now move on to the new stuff, which is the quadratic inequalities. Step 1, find the zeros. Step 2, plot the zeros on a number line. Plot the zeros on a number line. And then 3, test values. And this is something you will need to know how to do. It's big on the test, so you want to make sure you get the practice. All right, number 1, x plus 2, parentheses, x minus 4, close parentheses, is greater than 0. All right, so these are inequalities, but if I were to distribute this out, double distribution, I'd end up with an x squared, a quadratic type polynomial. So let's go ahead and do the steps. Step 1, find the 0. Recognize first that this says x is greater than 0, so it's not an equal to. But when you're looking for zeros, that's where you're looking where each piece equals 0. So you break it up, set equal to 0. Your zeros are -2 and +4. Plot the zeros on a number line. -2. +4. I look here to see if it's open or closed, and it looks like they're both open. And then I do my test values. And it says, okay, that's step 3, test values. And here is how you do your test values. You're going to test a value to the left of, you have two points here. You're going to pick a point on the left, in the middle, and on the right. A point on the left, in the middle, and on the right. Any point to the left, -5, -100, -3. Any point in the middle, -1, 0, 1, 2, 3. Even 3.5 would work. And any point to the right, 5, 6, 7, 8, 9, 10, even 4.5 would work. Okay, so I am just going to pick some not too crazy numbers. A number to the left, I'm just going to pick -3. You can try -4. A number in the middle, I'm going to pick 0. I like picking 0 whenever I can, and 0 happens to lie in the middle. And a number to the right, I'm just going to pick 5. You could pick 6 or 7 or 8 or any other number that is larger than 4. And here is how the test values work. We don't look at when it equals 0. We look at the original problem here, well, where it's factored, because sometimes you will have to factor on your own. So you look to where you have it factored with the inequality and then the 0, and you want to make sure that this part is always on the left of the 0. And we're going to plug in the -3 into those parentheses. And all I care about is whether it is positive or negative. I do not care about the value. I don't care if it's -100 or +100. All I care about is whether it's positive or negative, because I want to know if it's greater than 0 or less than 0. All right, so here's what you do. You plug the -3 in there. I'll write it in pencil and then erase. -3 plus 2 and -3 minus 4. -3 plus 2 is a negative number, so I'm just going to put a negative sign. -3 minus 4 is another negative number, so I'm just going to put a negative sign. And when you multiply two negatives, it ends up being a positive. So I'm just going to put a little plus sign there. And that would happen if I plugged in -5. -5 plus 2 would still be negative. -5 minus 4 would still be negative. And a negative times a negative will always be positive. So any number to the left of -2 will always come out to be positive. All right, I'm going to plug in 0. Again, I'm going to erase this. I'm writing in pencil. 0 plus 2, 0 minus 4. 0 plus 2 is positive. 0 minus 4 is negative. And a positive times a negative is a negative. All right, now that would have worked even if I had picked +3. 3 plus 2 is still positive. 3 minus 4 is still negative. Any number that I picked within this little region right here, -2, +4, would end up being a positive. Even if I had picked -1, you can see that here. -1 plus 2 is still positive. -1 minus 4 is still negative. It would end up being a negative. All right, +5. 5 plus 2, 5 minus 4. 5 plus 2 is positive. 5 minus 4 is also positive, and a positive times a positive is a positive. All right, so here is what, oh, let me put my positive in here. Here is how you end up shading. You look here, as long as your factored piece is to the left of the 0, you're good. This is greater than, when you read it from left to right, you would say blah, 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 blah is greater than 0 because it's eating the variable side, that this side is greater. Numbers that are greater than 0 are positive numbers, not negatives. So that means I'm going to shade on the positive piece here. I'm going to shade here, and I'm going to shade here. Why am I not going to shade here? because I'm looking for when it is greater than 0, and negative numbers are not greater than 0. This means any numbers to the left of -2, any numbers to the right of +4 would work for this inequality. If I plugged in any number within this region here, it would not be greater than 0, it would be negative. So negative infinity to -2, parentheses because they're open, union 4 to infinity. And this here is your answer. All right, we're going to try one more. X minus 2, x minus 5, x plus 4 is less than or equal to 0. And remember what I said earlier, if it's not factored, some of them will not be factored on your assignment. You have to factor it on your own. These have already been factored for us. Okay, everything's to the left of the 0, which is good. So we find our zeros. We find our zeros by taking each piece and setting them equal to 0. You can do that in your head. X equals 2, +5, -4. So we're going to plot those on a number line. -4, +2, +5, and it's, I look here, there's an equal bar, so they're all going to be closed. All right, I'm going to have to test it for more numbers because I have to pick a number to the left of -4, one in between -4 and 2, one in between 2 and 5, and one to the right of 5. So there are more numbers that I'm going to have to check. To the right of -4, I'm just going to pick -5. In between -4 and 2, I like to pick 0 whenever I can. There's, I'm going to pick the 0. Between 2 and 5, I'm just going to pick 3. You could pick 4 if you'd like. Bigger than 5, I'm going to pick 7. You can pick 6 if you want. Okay, 1, 2, 3. I always plug these numbers back into the original. 1, 2, 3, 1, 2, 3. For each one, there's 3 parentheses when it is in factored form. So that is what I'm going to test. Okay, here we go. Plugging in -5 minus 2, -5 minus 5, -5 plus 4. -5 minus 2 is negative. -5 minus 5 is also negative. And -5 plus 4 is still negative. And 3 negatives make a negative. Put a negative sign over there. All right. Now we're going to plug in 0. And this little pencil writing that I'm doing at the top, you don't have to do that. Like if you can look and say 0 minus 2 is negative, 0 minus 5 is negative, 0 plus 4 is positive, that equals a positive, you're good. I'm only doing that for visual effects so you can see what I'm doing. 2 negatives is a positive times another positive will stay positive. Okay, 3 minus 2 for those of you that are visual, 3 minus 5, 3 plus 4. 3 minus 2 is positive, 3 minus 5 is negative, and 3 plus 4 is positive. 2 positives and 1 negative will make a negative. And then our last one we're going to do is the 7. 7 minus 2, 7 minus 5, 7 plus 4. Okay, 7 minus 2 is positive, 7 minus 5 is positive, and 7 plus 4 is still positive. So I end up with a positive. Okay, according to this, this is saying this multiplied, this variable piece here is less than or equal to 0. Less than means we're looking for negative numbers, right? Because less than 0 means negative. Greater than 0 means positive. So I'm going to shade over here wherever there is a negative, which is to the left of -4 and in between the 2 and 5. I'm not going to shade these regions because anything here is going to be positive. So that means anything from negative infinity to -4, and 4 has a bracket, union 2 to 5, anything from negative infinity to -4 or 2 to 5 would work for this solution. This is the answer. any numbers between negative infinity and negative 4, so say negative 10, or between 2 and 5, like 2.5, or even 2 or 5, if you plugged any one of those numbers into this, it would be negative, a negative number less than 0. And that is it for this lesson.